Hi class, this is Mrs. Montgomery. I want to go over hypothesis testing, and this problem is testing a claim about a proportion. Let's read the question together. It says trials in an experiment with a polygraph include 98 results that include 24 cases of wrong results and 74 cases of correct results. Use a 0.01 significance level to test the claim that such polygraph results are correct less than 80% of the time. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, conclusion about the null hypothesis, and final conclusion that addresses the original claim. We're told to use the p-value method, and we're told to use the normal distribution as an approximation of the binomial distribution. So what I have here is I've listed out the givens from the information in this problem. I noted that we have 98 for n, the sample size is 98. P hat, the sample proportion, is 74 over 98 because we're told 74 cases have correct results. That turns out to be 0.755. The proportion that we're checking about is the 80% of the time, so that is 0.80. And then to find Q, we simply subtract P from 1 and we get 0.20. I've also listed that our alpha level is 0.01. So the first step in hypothesis testing is to list the null and alternative hypothesis. So what I have here is noting that the equal sign always goes with the null. Okay, we were told to test the claim that the proportion is less than 80% of the time. The correct results are less than 80% of the time. So that's the alternative, and I listed that that is also the claim. So the claim doesn't necessarily have to be the alternative. You have to read the question carefully to determine whether the null or the alternative is the claim. So I put the claim next to the alternative here. In step 2, I want to find the test statistic. So since we're dealing with a proportion and we're using the normal distribution, this is the formula that you'll use to find the test statistic z. It's p hat minus p divided by the square root of p times q over n. To do that calculation, you'll plug in p hat here, which is 0.755, and subtract p, which is 0.80, and then divide that by the square root of, you do 0.8 times 0.20, divide it by 98, and take the square root. Okay, that gives 0.0404 in the denominator. You can divide this out and we get negative 1.11. So that's our test statistic. Now let's look at the normal bell curve to determine the p-value based on our test statistic. So I've drawn out the normal distribution, z curve, the standard normal, and I've located on the graph where negative 1.11 is located. And because we're dealing with a left-tailed test, I know it's a left-tailed test because the alternative states less than. So that's a left-tailed test. Then I want to know the area to the left of my test statistic. And you can find that area using the tables, using StatCrunch, or using normal CDF on the calculator. And I got the area of 0.1334. That is the p-value. Okay, now the decision rule is based on the p-value and the level, alpha level. So the decision rule is if the p-value is less than alpha, then you reject the null. Now in our case, we see that the p-value is actually greater than our level of significance of 0.01. So that means we will fail to reject the null. Now we make our conclusion. So there's not sufficient evidence to support the claim that the polygraph results are correct less than 80% of the time. Notice I use the wording, I'm not supporting the claim, because the claim was the alternative, and based on our decision rule, we're not rejecting the null, which means we're keeping this, and we're not supporting the alternative, which is the claim. I hope this helps. Good luck, everyone.